So the problem name is binary inversion. It is also from CodeSafe Starter 70. So in this you are given n binary strings s1, s2 up to sn, each of length m. You want to concatenate all the n strings in some order to form a single last string of length n into n. Okay, we have given n strings of equal length n. Okay, and we have to concatenate all the n strings in some manner so that the number of inversions should be minimum. We have to concatenate these n strings in some order so that the number of inversions would be minimum. And what is the inversion? So let's see. A binary string is defined as a string consisting of 0 and 1. Yeah, we know that. And what is an inversion is an inversion in a binary string S is a pair of indices such that if I is less than j, in this I is less than j and Si is 1 and Sj is 0. So for example, the string S is 01010 contains 3 inversions 2, 3, 2, 5, 4, 5. So what is an inversion is like we have we will choose some pair I and j. In this I should be less than j, and s of I should be 1 and s of j should be 0. So if we take this string as an example, in this position contain 1, this is position 2, so this is 2, and what is the next 0, and what is the definition of inversion? We have to choose some position, some indices I and j, two indices. In this si should be 1 and sj should be 0, so the second indices should be 0. So if we choose this one, then we can choose this second 0 and this last 0, and if we choose this one, then what we can choose in place of 0 is only this. So the number of inversion for this one is 2. Like first choose this and then this, and for this one it's this. So there are only 3 inversions. Okay, so this is the inversion, and what we are going to do here is like arrange and concatenate all the n strings in some order so that this inversion should be minimum. And note that you are not allowed to change the order of the characters within any of the string. Yeah, okay, we know that. We cannot change this like uh, shift this 0 to some other place, yeah, or shift this 1 to some other place. We cannot do that. Okay, so what is the input format? We have given test cases, and every test case first line contain n and m number of strings and the length of the every string, and n line follow the string si string. Okay, we have to print a single line contain one integer, the minimum possible number of inversion. Yeah, okay. So let's see. If we have string 1, string 2, string 3 and string 4. So these are 4 strings which is of length, let's say 5, like 1 1 0 0 1 0 1 0 1 0 0 0 0 1 1 1 1 1 1 0. So we have to minimize the inversion. And what is an inversion? If it is 1 and whatever number of zeros here, like if number of zeros in the right of this one is 1, then the number of inversion is 1, and if number of zeros is 2, then the number of inversion will increase by 1, and if it is 3, then like number of zeros equals to number of inversion which is for this one. And if I have one more one is here, like 1 1 0 0 0, so for this one, what is the number of zeros in the right? 3. So the number of inversion for this one is 3, and for this one same, these 3 are the number of zeros for this, so the number of inversion in this case total is 6. So if we have to minimize this inversion, what can we do? So if I want to minimize this, so what can I do is just decrease the number of zeros in right of this, right of the one, everyone. I would like to do decrease the number of zeros from the right of one. Okay, so we cannot change the order within the string. What we can do is we can only change the order of the whole string. Like we can put this string as a first or second or at third place or at fourth, and we can do this for every string. So what we can do is just count number of one in this string. Let's say this is 3, and in this it is 2, in this it is 2, in this it is 4. So what we are going to do is contain whichever string has more zeros, just take it, just place it in the left. Like number of inversion will increase if number of zeros on the right side of a 1 is greater. So what we are going to do is we are going to arrange them in some manner, like in left there are number of zeros, in right there are number of ones, maximum number of ones. So we can what we are going to do, we are going to just change their place so that in half of them number of zeros will be greater than the number of one, or we will try to minimize it. So in this case number of ones is 3, and in this 2, and in this 2 and 4. So what we are going to do is just put whichever one is greater, or we can think it in zero form. Like how many zeros in this? 2. How many zeros in this? 1, 2 and 3. How many zeros in this? 3 and 1. So we are going to put 0 in right. So this is the maximum number of 3, 3, and after this 2 and then 1. So what we can do is just put whichever has maximum zeros. Just put those string first. Like if we put this string first, then the number of zeros in this case will shift to left, and then put this string to the left. In this also the number of zeros is greater, then put it in the left of everyone. Okay, so if we do this, then we will minimize the number of inversion. So how are we going to implement it? We will see in the code part. So here is the code part. In this I have I have taken the input NNM. First of all, this is the test case, same T. Okay, and I'm calling this solve function from this. So in this I am taking input NNM, and after that I am creating a vector of string SN, which will contain all the strings. So this is ith string. Okay, now what I am making here VPII is, this is a vector of pair. Which type is it? So this is this vector of pair, answer n. I am denoting it with answer, and n is the size. So what I am doing in it is create for every string I am counting number of ones in it and storing it in the vector pair intent. First element number of ones and another is their index. Okay, is the number of it is the string number. So 0th number of string has this number of ones, x number of ones. Okay, so I am counting this for every string, and at last I am sorting it in the increasing order. St is this sort function, like answer dot begin, answer dot end. I've just wrote it down in the easiest way so that I can write it fast. So I am sorting it on the basis of first element. Okay, and string res is a resultant string, like after concatenation. So I am adding what we are going to do here is this x, this answer is sorted according to a value of x, like number of ones. Okay. So I am storing the string which have lesser number of 1 or in other case lesser number or greater number of zeros in the left. So this is our resultant string. Okay. So now after that I am creating a vector of int vi is vector of int. It's just a vector. Okay. Vector of int and denoting with prefix. So what I am doing here is I'm just marking the position in which there is a 0. So if res of I is 0, I am just pushing a 1, and if not, I am just pushing 0. If it is 0, I am pushing 1, and if not, I am pushing 0. And after that, I am making a prefix array of this, a suffix array of this pre, in which, like for example, if I have 1 0 1 0 0 1, so 1 means I have 0 here, 0 means I have 1 1, and here I have 0. Let me write in next line. 1 means 0, 0 means 1, 1 means 0, and 1 1 0. So what I am doing here, I am just making their prefix, like at this point number of zeros is 0. At this point number of zeros will be this plus this value, which is 1. Like let me write that way. I'm making suffix array. So number of zeros at this position is 0. Number of zeros at this position is 1 plus 0, so which is 1. And number of zeros at this position is this number plus this number, so this is 2. And here it's 0 plus 0 plus up to this number, which means 0 plus this number of zeros up to this number, plus number of if 0 is present here, plus 1, and if not just plus 0 or whatever. So here it is 2, so it is 1. So 1 is present here, so 1 plus number of zeros up to this position, so it is 2. So 1 plus 2 is 3. So that way I am making suffix array of this. Okay, and P is my answer, is my final answer, number of inversions. So what I am doing is I am traversing the resultant string, and if I found 1, then I have made a suffix array. Then if I have 1 in is 1 in this place, like 1 2 3 and 4 5, like if I have the only 5 element and I encounter 1 at second position, then what I am doing is just counting zeros up to this position. Like what is the inversion? Number of zeros in the right of 1, that is the number of inversions for this one. So what I am doing is, if I am encountering 1, then I am just adding number of zeros up to this position into our answer P. So I am doing it for everyone, and this is in that way this is the minimum number of inversions. So I am just printing it at the end. So this is the number of inversions after minimizing. So that's the code. I will add it into the description. That's all.